So yeah, hi. Yes, I'm Simon Frost. I work for the Architecture and Technology Group in Arm. I was due to be joined today by Thomas Fossati, who works on the same team, but he has suffered a technological thing and that has found a place in the world where the user does not actually have access to the internet. So he can't join us this afternoon. But I'm not here as particularly as an ARM person. I'm here as one of the core team members of Project Veraison. That pronunciation is very important. As I would say, it's all about the verification of attestation. So before we go into the project, I'll talk a little bit about why, the setting the scene, why we got there. The top quote is from the Confidential Compute Consortium, and talking about data being protected in use by working in a hardware-based trusted execution environment. So if someone is using one of those trusted execution environments for a confidential compute service, it's really difficult to tell. You contact a service and you have to trust it. You must be able to trust that really is a confidential compute service, and you must be able to establish the trustworthiness of that in the environment. And the way that is done is attestation. And attestation is a means of getting some evidence produced but from an entity, the entity you are trying to establish trust with, signed by a trust anchor, which is the mechanism of proving its things like that. That's fairly complicated, but just getting the report is not sufficient. I think we saw with the discussion in the end of the previous session about sort of the mechanisms of producing attestation reports. But getting the attestation report is only half the story. The report must be actually verified to prove the constituent claims. Now you can break that down to its various parts. You usually get a blob. If you are the receiver of the attestation report, you just get a binary blob normally. So you'll have to deserialize that, check the syntax is as expected. The trustworthiness parts start coming in. You need to check the cryptographic signing, and that needs knowledge of the relevant trust anchor. That may be very common if you have something like a certificate chain and you just need to know the root of that chain, or it may be something you need to know the identity of the individual key that's signed it. You may need to be able to establish the public key that you need to match the signer. If there are measurements within the claim, you need to check those. Those need to make sure that these are as expected. They are usually from measured boot or something that's similar. There may be signer information from secure boot, and these are drawn from the supply chain. And we'll talk about that in a minute. That can be fairly complicated. And there may also be necessary to do something like apply semantic relationships between claims. It's all very well to say, okay, well, this piece of hardware is capable of confidential computing, but it may need a certain set of firmware components or additional supporting trusted elements in there to be confident that it relieves things like that. And the verifier itself, well, there's a big set of trust invested in it. You can do this operation in theory by anyone receiving the token could do this, but you need to get all this information in. So if we look at, and I reckon this is a slide taken or an image taken from the IETF Remote Attestation Working Group architecture document, and I'd recommend that if you want to learn more about attestation, that you seek out their work. There's a link there, but IETF RACS Working Group is highly verifiable, highly Googleable. The image there is you can see that the verifier sits in the middle of everything else. There are potentially complex interactions to be able to get hold of an attestation report and to be able to secure it within an attester. But the verifier sits in the middle of all this. And the verifier, as I say, it takes all this information, which it needs to establish the TCB is accurate for a CC environment. So the supply chain is, yes, all of these elements you see here are potentially part of in things that you need to know in order to establish the TCB. They are either reference values or endorsements in RAT's language that you need to know, and the true nature of them has to come from potentially multiple actors. This is why it's very complicated to do this if you are just the piece of software that gets is the relying party, just gets the attestation in. In theory, you need to not only have this set of information, but you also need to make sure it stays up to date, so it's dynamically encoded like that. And the verifier sits in this picture in this way, is that all of that information potentially flows to the verifier, and then the verifier can potentially also have interaction with other components, such as a certification authority. You can do a correlation between the information it's found in the evidence and other information that's there. This also works in-house for an enterprise model. If it's a set of managed devices, is that an enterprise admin can have this same relationship. They can sort of review their device catalog, go off and scan devices, and compare information against the information they've got from a golden device, and then that gets refreshed should they need to change their golden device. So it's a similar model. So we last get to Project Veraison. Given all of this, the complexity I've been trying to outline, which is related to sort of you potentially have a lot of data sources, you potentially have a lot of different types of hardware, of technologies, architectures that you are trying to include into a confidential compute service, and if every deployment has to do their own thing, has to roll their own verification service, then you end up with something that's going to of variable quality, which means it's harder to trust the verifier. You need to trust the verifier because it's going to do a complex set of roles for you, but it gets harder to trust that. And also, building a verifier is a barrier to entry. So, Project Veraison, verification of attestation. The point of this project is to build software components that in turn can be used to build attestation verification services. It's an open source project, it's fully open. ARM staff the core team. The intent is to encourage collaboration. The work is not just aimed at ARM stuff, it's aimed at sort of industry-wide things. We're embracing standards wherever possible, and we'll be working on multiple targets because that's a good way of making sure the software is designed properly. So it's designed for flexibility, extensibility, so that taking into account, we'll also be able to sort of test theories how it works. So whether it's public cloud, private cloud, wherever, it could support many different tokens at the same time, token types at the same time, or it could be dedicated to a single type. You can have multiple or single tenancy in terms of your supply chain, so those could be or dedicated. Service verification is the normal pattern, especially for confidential compute, but it's not limited to confidential compute. We're also, there is a lot of set of conversations. We have in the core team have a background in ARM's PSA, platform security architecture, which is more IoT oriented. And so that works equally well for as things like that. And the software components, in theory, could be deployed on a local basis. So if you have some way of saying, an isolated, trust is important here. So you could maybe put something in trust zone or something like that. The architecture splits into 2 points: being able to define the data formats, so being able to identify reference values or endorsements all the key parts of these things as it go through the system. These need to be identified, handled against certain models, and then what that exposes is then those are made available to pipelines which have common functionality. One is for verification, and the other is for provisioning that data in and making it available suitably for the provisioning pipeline. So format part, as we can take in multiple forms of multiple items, multiple reference values, multiple endorsements, and there's some standardization work in terms of co-mid and co-rim, which I'll talk more about in a minute. That flows into the verifier. Similarly, the attesters can produce a variety of different token formats, and there's a lot of work able to produce implementations that support the various particular underlying technologies or architectures in that. Then this information flows into the two main pipelines, the provisioning one, which is needed to set up the data which the verification pipeline uses to be able to check things like that. And there's these common part of that is an endorsement store. We're actually just doing a slight refactoring, and there will actually be the endorsement store is going to have sort of general functionality and a virtual technology service on the front, which is where all the smarts go for a particular format. For another wine show, we pronounce that Edgeless. So I've tried to explain how, and I'm trying to have going slightly faster. My timing has been slightly thrown, but as I said, we're trying to make things extensible and pluggable. So both the provisioning pipeline and the verification pipeline have a common form and then can take plugins. So, for example, it takes a plugin which be able to understand that if I've got a set of information coming in on a reference value, how I can transform that to be ready in the endorsement store for subsequent queries. And the endorsement store is an abstraction in itself, and then that can actually be layered over different technologies. So we have, depending on what you're trying to do, it may be useful to use a graph database or a simple SQL or just bulk lookup. And the endorsement store, works over a set of abstractions, which are driven by the needs of the particular technology plugin. I mentioned we were collaborating on some standards work. The data entering the provisioning system is going to be based on some work that's coming out of both ITF and TCG, unusually at the same time, on co-rim and co-mid. If you're familiar with some of the work that's been done on SWIDs or co-SWIDs in the past, those are really good for identifying high-level pieces of software, less useful for identifying things like pieces of firmware. So there is the rim is a document format, a data model, which can be used to describe reference values or endorsements. And then co-rims are made up of sort of module identifiers, which define the sum of these can define a system or a device, and the co-rims can be signed to produce this, and then the relationship between the data pieces and the targets are defined by sets of triples, which defines the exact relationship between a target and a particular set of values. And we think that by targeting a standard for this data coming in, that it will make interop more easy. We're aware that supply chain I put up earlier may be producing information on this stuff already in some custom form. If we're asking them to transform, it's much easier if they transform to something that is standard, and there may well be work or libraries already available that implement the standard on this stuff. And we think that it's going to make it easier over the medium to long term if we actually work with a standard rather than having to try and transform stuff from it in a custom form. That's helped by some work that's been done. There is a CLI which has been produced to help some of this work. It makes it easier to build the co-mid type pieces from that stuff. And that can be found in its own repo in the Veraison project. The verification pipeline, again, designed to be extensible and pluggable. As we can see at the same time, the technological pieces that fire in, and the for the particular token formats and the requirements of those token formats. And essentially what happens is that when the token is sufficiently unpacked, the evidence is extracted and it's put into a common form by the understanding of the deserialization and pieces like that. And then the necessary is a set of queries that can be made to the endorsement store to get the data that is necessary to validate a claim. So, if I've got a claim and it has a measurement in it, what I really need to know is that a known measurement and pieces like that. And this flows down the pipeline until it gets to some set of attestation results, which can be signed. And go out to returned to the caller, the relying party caller who has submitted the request for verification. There's also a policy step, which I'll talk more about in a moment. The attestation results can come in various forms. This is the conversation, if you like, is that the relying party is someone who has interacted with an attester and got an attestation result, an attestation token. They submitted that to a verifier, and they need some results. And essentially the results are a more readable form of the conclusions of the verifier. And that can be simple. It can just be a Boolean going, yep, that was fine, or no, some problem. It can be the endorsed claims. It can say, actually, I found these claims and I have validated them. It can be derived. If I was talking about, the ability to correlate information against the external party, and that's what we call derived claims. Or alternatively, we can have a normalized set, and there's some more work in the IETF on this, which is basically saying, I may have multiple technologies, but actually I can normalize them down to a set of common terms, like my hardware is suitable for this date, or my firmware is all being validated, my firmware is up to date, things like that. And there's some very interesting work going on that, and with actually some of the earliest implementations of that are in Veraison. And it's selectable. It will be selectable what form of result you'll be able to get out of the project. Appraisal policy is, if you like, the last stage of the pipeline, and this is an optional piece of the pipeline. However, it's quite an important one, because if you need to make semantic decisions for the profile, it's all very well saying, okay, I have the token and I have checked the values in it are known, are good, but there may also be, and this is maybe particularly important for things like confidential compute, certain other correlations you might need to make. So for example, okay, I know it's this hardware, but I do expect to have the following set of firmware components, or I want to see a trusted subsystem also present. And that's something that you might need to run by policy, which is more, an arbitrary. It's not a mechanical testing against each component. So we support a policy stage. Again, it's pluggable, but we're working on a system based on the Open Policy Agent, and that will take Rego inputs to be able to policies. And that's probably also how some of the derived claim work will work. Okay, so the output of the project are the components I've talked of, the pipelines, the formats. And but you need to turn that into a service. So there will be reference implementations for containers and a public cloud, and that will be built over an abstraction. And will also include the kind of things you need for a service, like understand the concepts of audit trails and multi-tenancy and stuff like that. The scaling concepts within the project is that something like the verification pipeline will exist in something like a compute unit and will have appropriate instrumentation within that unit, and you can then build scale up of that so that you can ask for additional compute if that's the basic level of context. Project status: it's up and running, active on GitHub, has open governance, weekly meetings. We have a Zoom channel to conduct business. The project is underway for donation to Confidential Compute Consortium. It has TAC approval for that. As I say, this does not mean we won't work on non-CCC projects, but we think that's probably the strongest community to attract collaborations in this area. The project runs on a set of demo stones, roughly quarterly to half year, where we're just trying to say we can show that we are working against live environments. The current demo stone works on, but we'll be able to prove validating a PSA token based on provisioned data. The previous demo stone was against fixed data. And there's also an interesting collaboration, our first sort of collaboration with external contributions from outside the core team, from the Enact Trust team. Enact Trust have a more of the enterprise model I was talking about earlier, where they can aim at sort of mostly TPM based environments, and they have a nice video up there. I'll let you visit it in your own time, of the integration between the product. Previously, they did all this work themselves, and they've split this apart to use Veraison components for the provisioning of data discovered in the enterprise and for the verification passes. And that is a nice screenshot from their demo. So that, I hope I was not too fast, too slow, given the hiccups. And I hope that's clear, and I will be in the Q&A session immediately following this if you have questions. Or come and visit us on GitHub or on the Zoom channel.